The hidden journey of gold. Gold is everywhere, in vaults, in smartphones, in wedding rings, and in national reserves. But very few people ever see how gold is actually made. Before it becomes a polished bar stamped with serial numbers, gold begins its life invisible, locked inside rock, dirt, and mineral veins formed billions of years ago. Today, we're entering the restricted world of modern gold processing facilities, where raw ore is transformed through engineering, chemistry, and extreme precision into 99.99% pure 24-karat gold. This is not mythology. This is not speculation. This is a real industrial process. Step by step. Welcome to factory intelligence. Gold in its natural state. Gold does not occur as neat, polished nuggets waiting to be collected. In reality, most of the world's gold is completely invisible to the naked eye. Inside modern mines, gold exists as microscopic particles, often thinner than human hair, locked deep within quartz veins, sulfide minerals, and dense host rock formed millions, sometimes billions, of years ago. In many cases, a single rock contains thousands of mineral grains, yet only a few of them hold trace amounts of gold. To put this into perspective, producing just 1 ounce of refined gold may require processing over 30 tons of raw or an amount of rock heavy enough to outweigh multiple passenger vehicles. That extreme imbalance between effort and reward is what makes gold mining both expensive and technically demanding. To access these deposits, mining companies rely on 2 primary extraction methods. Open-pit mining is used when gold-bearing rock lies closer to the surface. Entire sections of earth are carefully removed in massive, terraced pits using excavators and haul trucks the size of houses. When deposits are located deeper underground mining is required. Vertical shafts descend hundreds or even thousands of meters below the surface, branching into tunnels where miners extract or under tightly controlled conditions. Once removed, the ore is loaded onto heavy-duty haul trucks, some capable of carrying more than 300 tons per trip, and transported to nearby processing facilities. At this stage, the material looks ordinary, dull, rocky, and unremarkable. But hidden inside this unrefined stone is one of the most valuable and trusted metals on Earth. Crushing and grinding, freeing the gold, once gold-bearing, ore arrives at the processing plant. The first challenge is purely mechanical. At this stage, the gold is still completely trapped inside solid rock. No chemicals can reach it. No separation is possible. The only solution is to physically break the rock apart until the gold particles are fully exposed. This process begins with primary crushing. Massive industrial crushers apply extreme pressure, reducing boulder-sized ore into smaller, fist-sized fragments. These machines operate continuously, handling thousands of tons of material every hour. The crushed ore is then transferred by conveyor systems into grinding mills, where the real transformation begins. Inside these enormous rotating drums, the ore is mixed with water and heavy steel balls. As the mill turns, the balls collide with the rock repeatedly, grinding it down further and further. Over time, the solid material is reduced to a fine, sand-like powder, suspended in water to form a thick slurry. This slurry allows gold particles, many of them microscopic, to be fully released from the surrounding rock. Grinding is one of the most energy-intensive stages in the entire gold production process. These mills can consume as much electricity as a small town, but despite the cost, this step is absolutely essential. Without crushing and grinding, no gold can be chemically extracted, and the entire process comes to a halt. Leaching, dissolving gold from rock. Once the ore has been crushed and ground into a fine slurry, the process shifts from mechanical force to controlled chemistry. The slurry is pumped into a series of large leaching tanks, some of them several stories tall, where gold is separated from the surrounding waste minerals. Inside these tanks, carefully measured chemical reactions take place. Most modern gold processing facilities rely on a cyanide-based leaching system, selected not for simplicity, but for precision and efficiency. Cyanide has a unique ability. It bonds strongly with gold while leaving most other minerals untouched. Under tightly controlled conditions, a dilute cyanide solution is introduced, oxygen is added to accelerate the reaction, gold particles chemically dissolve into the liquid. As this happens, the gold transitions from a solid metal into a dissolved state, becoming completely invisible within the solution. Modern leaching systems are heavily monitored. Sensors track chemical levels, oxygen flow, temperature, and reaction time in real time. Contrary to outdated assumptions, today's gold plants operate under strict environmental and safety regulations. Closed-loop circuits prevent chemical release, and detoxification systems neutralize waste before it ever leaves a facility. By the end of the leaching stage, the rock has been stripped of its value. The gold is no longer solid. It no longer looks like metal. At this point, the gold exists only as chemistry, suspended, dissolved, and ready for recovery. Carbon recovery, capturing liquid gold. After leaching, the gold no longer exists as a solid metal. It is fully dissolved within a liquid, spread invisibly throughout thousands of liters of solution. Recovering it requires extreme precision. The gold-rich solution is pumped through tall columns filled with activated carbon, a highly porous material engineered to trap gold at a molecular level. As the liquid flows through these columns, something remarkable happens. The activated carbon acts like a selective sponge. Gold molecules attach themselves to the carbon surface, while the remaining solution, now stripped of value, continues onward. This process is known as carbon adsorption, and it is one of the most critical control points in the entire factory. Once the carbon becomes saturated with gold, it is carefully removed and transferred to a separate recovery system. Here, heat and chemical treatments are used to strip the gold from the carbon, producing a much smaller volume of highly concentrated gold solution. At this scale, precision is everything. A minor miscalculation, incorrect flow rate, temperature, or timing can result in millions of dollars worth of gold being lost. But when executed correctly, this step delivers gold exactly where engineers want it, ready for final recovery. Smelting, fire, and separation. After electrowinning, the gold has finally been recovered as a solid material. But it is still far from pure. The gold-rich deposits scraped from the cathodes are first dried to remove any remaining moisture and chemical residue. What remains is a dense concentrate containing gold mixed with other metals and impurities. This material is then transferred to industrial smelting furnaces, where the process enters its most visually dramatic phase. Inside the furnace, temperatures rapidly rise beyond 1,060 degrees Celsius, exceeding gold's melting point. As the heat increases, the solid concentrate liquefies, transforming into a glowing pool of molten metal. At this stage, technicians add carefully measured flux compounds. These materials are designed to react with unwanted elements, such as iron, silica, and other residual metals, binding them together. As the furnace continues to operate, these impurities separate from the molten gold and float to the surface, forming a dark, glass-like layer known as slag. The slag is carefully removed, leaving behind a cleaner molten gold layer beneath. Once the separation is complete, the molten metal is poured into molds and allowed to cool. The result is the formation of door bars, semi-refined gold bars that typically contain a mixture of gold, silver, and trace elements. These bars represent a major milestone in the process, but they are not yet pure enough for investment or industrial use. For that, they must be sent to specialized refineries, where the final and most precise stage of purification begins. Chapter 7, Refining, achieving 99.99% purity. Refining is the moment where gold reaches its highest value. Up to this point, the metal has been recovered, melted, and partially purified, but it still contains silver, trace metals, and microscopic contaminants. To transform door bars into investment-grade 24-karat gold, refineries rely on advanced, tightly controlled processes designed for absolute purity. The first stage is often the Miller process. In this method, door bars are remelted inside specialized furnaces. Once fully molten, chlorine gas is carefully injected into the gold. Chlorine reacts with impurities such as silver, copper, and base metals, forming compounds that rise to the surface where they can be removed. The Miller process is fast and efficient, raising gold purity to approximately 99.5% in a single step. But for the world's highest standards, this is still not enough. To reach 99.99% purity, refineries turn to the wall wheel process, one of the most precise metal refining techniques ever developed. In the Wall-Will process, gold is dissolved in an acid-based electrolyte solution and placed into an electrolytic cell. When a controlled electric current is applied, pure gold selectively deposits onto cathodes, atom by atom. At the same time, impurities fail to deposit and instead remain in solution or fall away as residue, where they are collected and processed separately. This slow, deliberate method can take several days, but it produces gold of exceptional chemical purity, suitable for central banks, bullion markets, and high-precision industries. Once refining is complete, every batch undergoes strict laboratory verification. Samples are tested using fire assay techniques and X-ray fluorescence analysis to confirm exact purity levels. Only gold that meets international bullion standards is approved to move forward. Anything less is rejected and refined again. At this stage, the gold has reached its final form, 99.99% pure, 24-karat gold. Final casting, security, and distribution. Once the gold has been refined to 99.99% purity, the process enters its final and most tightly controlled stage. The ultra-pure gold is melted once more inside precision furnaces, ensuring complete uniformity before casting. At this level of purity, even minor inconsistencies are unacceptable. The molten gold is then poured into molds to create its final forms. Depending on its destination, the gold is cast into investment-grade bars for global bullion markets, coins produced exacting weight and purity standards, industrial forms used in electronics, aerospace, and high-precision manufacturing. As each piece cools and solidifies, it is permanently stamped with critical identifying information, including weight, purity, refinery marks, and unique serial numbers. These markings ensure traceability and authenticity throughout the gold's lifetime. At this stage, security becomes absolute. Refining facilities operate under strict access controls, including biometric identification, continuous surveillance, and heavily restricted work zones. Movements are logged, audited, and monitored in real time. In many facilities, armed security personnel are present at all times. Once cleared for release, the finished gold is carefully packaged and prepared for transport. From here, it enters the global supply chain, moving through armored vehicles, secure vaults, and international logistics networks. The gold's journey ends in banks, central reserves, manufacturing plants, and private investment portfolios around the world. What began as ordinary rock has now become one of the most trusted stores of value on Earth. Conclusion: from dust to treasure, gold's journey is long, complex, and unforgiving. It demands engineering precision, chemical mastery, and constant control at every stage. From the moment rock is pulled from the earth to the instant pure gold is sealed and secured. What begins as unremarkable stone, indistinguishable from millions of others, is transformed through science and industry into one of the most trusted stores of value on Earth. Few materials undergo such an extreme transformation, and fewer still carry the same weight in economies, technology, and history. Now you've seen the entire process. If you value clear, in-depth explanations of how the world's most valuable materials are made, subscribe to Factory Intelligence and explore what's hidden behind the machines that power our world.